As a society, we are called to address the complex challenge of mitigating climate change and creating a better and more sustainable future for all. But meeting these challenges requires never-before-seen innovation coupled with widespread deployment of new and emerging energy technologies.
And much of this is already happening offshore. Countries around the world are opening new offshore frontiers by harnessing technology to develop offshore wind and floating solar, while also producing hydrogen and capturing carbon offshore. In the United States alone, offshore wind is forecast to grow significantly over the next decade, with more than 13 offshore wind projects expected to come online by 2026.
Likewise, new developments in floating solar have helped expand on a decades-long innovation of utility-scale solar, while solving complex water conservation issues around the world. And others are championing green hydrogen production offshore and harnessing the power of ocean currents and waves to produce energy. With growing momentum for renewables in the offshore space, the future of energy looks bright.
And this August, the industry's best and brightest will convene in Houston for the Offshore Technology Conference to discuss, deliberate, and share ideas, forging the path to a low-carbon future. We hope to see you there.
Hello, everyone. Welcome to our Shallow Water iEPCI webcast. My name is Tony Manzer. I'm with TechnipFMC. I manage marketing for our surface division. Shallow Water iEPCI allows you to unlock your field development potential. TechnipFMC is transforming marginal fields into profitable energy infrastructures for our industry partners. Our innovative ecosystem of proven shallow water solutions delivers true economic benefits within the jackup drilling environment. Today, I have the privilege of introducing to you Mr. Ian Duncan, who is Vice President of Integrated Offshore Production here at TechnipFMC. Ian has been developing innovative solutions within the oil and gas space throughout his 40-year career, working with and mentoring some of the industry's key innovators. This background has enabled him to push the boundaries on drilling and production controls from the early 80s with the introduction of fiber optics to developing self-contained satellite-activated emergency well containment systems. Taking a practical and lean approach to solution development, focusing on safety and the overall commerciality of the technology, which has been his guiding principle throughout his career. Ian is currently working within the product management group and with a dedicated team to incorporate the lessons learned from our successful subsea iEPCI ecosystem and bring them into the shallow water environment. His team's focus is on delivering a transformational step change to enable our customers' marginal offshore developments in tight economic conditions. During his presentation, Ian will walk through the overall philosophy and guiding principles employed to take a bespoke process and turn it into a product-style deliverable, the focus of which will be safety and performance through system integration and turnkey execution. The resulting solution can deliver a robust yet economic development plan to meet your shallow water project requirements while maximizing the potential to future-proof the system design. Ian, how are you? Good morning.
I am well, Tony. How's things? Thanks very much for the introduction. Okay. You ready to start slide and I'll take it over from here.
Sure, let's get started.
Okay. Well, thanks very much. I appreciate the introduction. Like everything else, I would like to just to frame the conversation before we start. And to do that, I'd just like to explore the drivers behind why we started to have a look at this in the first place. Throughout the development, we as a group of individuals have always been struggling with trapped reserves. Now, there's various odd ways that we can actually look at this, whether you call them trapped reserves, stranded reserves. They're more or less areas of high potential that we can't get to an economic point to meet internal sanction. And part of the reason that we were driven down this road was to see what we could do, bringing the understanding and the technology that we gained from the subsea iEPCI into the surface business within Surface International, to see if we can make a step change to enable some of these pooled reserves to come to the front. Now, there are numerous different areas, and the example you see on the screen is just a typical where you have a host where you know what you've got in a stranded reserve a small distance away. And there are many areas that affect the economics to enable these pools to be actually developed. And one of those things is just product incompatibility, for instance, where the material coming out of the ground, your actual product, is incompatible to your nearest host, whether it's yours or somebody else's, for numerous means. You can, maybe the product makeup is too difficult, where you maybe have water cut and you can't handle that in a host. So we had a look at this and how can we make a material change to the customer to enable these small pooled reserves to be economically developed. And with that, I'd like to take you through the next phase of how we came to look at it. So I'll just set the stage. Tony, if you could go to the next one. So I'll use this diorama just to explain where we're coming from. And again, this is leveraging everything that we've learned from our successful subsea iEPCI business unit, but taking it into a product portfolio. And by product portfolio, I mean proven products that we've done for a number of years that have been configured to work in the shallow water space. And just to re-emphasize the shallow water space one more time, we're referring to shallow water space as jack-up drilling. So if it's in the jack-up frame, that's what we're referring to as shallow water. So that provides a little bit of context for you. But when it comes to the products that we're bringing into this space, we're bringing in our rental exploration wellheads, surface and subsea trees, our platforms, product-driven again, umbilicals, flow line, and overarching and bringing everything together is our ability for the installation and operation. So it's more or less taking all of these products we've got, packaging them into a solution that we can actually take forward. And one of the key drivers that we're using in this is our ability to provide a holistic solution to the customer. Now, holistic, what do you mean? We're not focused on a subsea solution, a platform solution. It can be a mixture of both. So our main goal is to try and get it to the point where we can affect the economics and make everything work. And part of that is we're moving away from pre-feed and feed studies, and we're going straight to work direct with the customer to provide them the most optimum solution. Okay, Tony? So let's just have a look at understanding what the ecosystem is. And we use the term ecosystem quite a lot, but this refers to our 4 pillars that you see here in front of your screen. And it really is about integrating a suite of solutions within one deliverable. And that's a complex thing to actually say, but that's where it is, where we work with the customer from the get-go, and we take everything through in a stage thing and figure out what products best suit the application. And we'll touch on that in the next slide. And then overall, how does that come together to deliver a safe and efficient system? And the safety is one thing that we had right from the get-go, and it was safety through design. So as we're building up the design of the systems for all these different shallow water applications, the overarching thing is how can we provide the most safest system out there that reduces CapEx and OpEx and provides a suitable platform for moving forward. And as we go down there, it's all based on building blocks. And building blocks are the key to this. Okay, Tony? So this is one of the best things that we can actually take forward. And this is, field development and the partnering. And this is where we get into intelligent packaging. And when we're working with the customer, we're working with the customer at a very early engagement point. And that's important if we're ever wanting to get any form of efficiencies into the field. It's also one of the most rewarding parts of the solution that we're presenting today. It's the engagement with the customer very early, where we can take the raw data that he has and any previous work that he's had, because many of these fields have been looked at over years. but they can never actually get them to an economic point. And it's incredibly rewarding to work with a customer from the very start, sit down in a room, explore what their thoughts are, bring the technology from the TechnipFMC point of view, work together as a single team, and literally develop the solution together as we move forward. And then that solution can then lead on to deliver the field development plan, and we can take that forward as well. And that's probably one of the most rewarding parts of the entire job, is watching a team come together, look at a solution, see the problem, and take it forward. It's very rewarding. And again, it's just one project and one team, and that one team is very transparent, which is one thing to remember as we go through this. And once they get a solution, it's easy to see how the products fit in, and then how we can actually integrate the whole hardware and then take that forward into a simple design. Okay, Tony. So simplification and standard products. Now, standards used quite a lot, but there's always configuration that has to be taken care of. What we did when we looked at the shallow water space and the equipment that we can actually bring into it, it was very much we needed to establish fit for purpose, good standards that could be manufactured economically and repeatable. And we also looked at all the products within the scope from a long-term longevity. And we focused on products that had a known track record of uptime, so that we're building in a higher degree of integrity into the solution that we come. Because the overall goal in all of these things is to make them safe, and by making safe, you remove the need to go offshore to sea. So it's very much working within that curve. And that comes down to the selection that you see there. And I just put up a couple of pictures in there. Umbilicals and flow lines configured to suit the shallow water space. Modular platforms, which we'll explain a bit later on. Our JXT3 systems that cover all our subsea hardware. JXT in acronym is just jack up Christmas tree. And then different subsea peripherals, whether it's manifolds, inline wise, to enable us to link the fields together. But having the ability to provide standard components that are easily manufactured, and more importantly, understandable by the people that are actually going to be using the technology, it aids to getting the whole system up and running quicker. Now, faster delivery time is what we've been looking at as well. So everything has to come within a short cycle time. And if you want to control the costs on some of these marginal fields, the best way to do it is to compress your schedule time. So we've done everything within the standard products. We've reduced weight in a lot of the cases and the overall size of the package without compromising the integrity of the individual solutions, to enable us to actually get them offshore, get them easily transported, get them installed using lighter weight assets. Now that lends itself a lot easier, because if you can get access to assets that are already there, it makes it easier for us to plan out the schedule and compress it. So all of the deliverables are linked into providing short cycle time manufacture, ease of installation, and ease of commissioning and handover. And again, that just adds to the greater uptime, as you see in the bullet point below, and the reduction of any intervention cycles. Okay, Tony? So I thought I'd put this one up just to give you an understanding of what are the main attributes of the system. And we're just going to focus on what's in the central column. These can either be tied back, all these developments can be tied back to an infield host, FSU, or they can actually go all the way back to the beach if it's within a suitable distance. But again, within that, it's all proven technologies. And you see in the foreground there, the JXT3 systems. It's proven technology used worldwide, and it's configurable for running from a jackup. And all of the solutions here that you see in that foreground there, the platform, the subsea trees, can all be installed from the jackup. And that's a complete platform installation of the subsea trees, where we can actually use the jackup as the main installation component if necessary, or we can use our vessels to do the same work. But it's all proven technology tied back. So this particular diorama shows a nice little platform in the middle for a subsea development. You're tying in the 2 subsea satellites there. So it can really be a mixture of both. But the platform is one of the key. As we were speaking about on the very first slide, one of the issues is the fact that sometimes you get product incompatibility with the host. This is where a small lightweight platform like this can come into play, where you can either drill the wells direct vertical access, have limited processing ability to match the product to your host. And we've got plug-in modules that I'll explain just shortly about that. But it's the ability to use the building blocks to find solutions to make the field feasible. And that's what we've focused on within this. I'll give you a little bit of background on the platform because I dare say a lot of you are familiar with the subsea tree solution. You won't be familiar with the platform solution. These are lightweight, patented modular platforms. Basically, it's providing offshore real estate within the shallow water space to enable us to go forward. So they're pre-engineered modules, 1, 2, or 3 modules within the platform system. You've got a lower base, a jacket connector, and an upper deck. The upper deck is uniform. The connectors can vary in length, and there are 2 bases that you can actually choose for. But they're clicked together. So you can install the lower base, you can add a jacket connector to give you the water depth region you want, and then the deck is the upper section that gives you green water clearance. Now, they're clicked together, and that's one of the key things because these platforms are reusable. Now, if you have a look at marginal fields, they can be very marginal, where you're getting a life cycle of approximately 3 to 4 years, sometimes 4 to 8 years if you're lucky. But what do you do after that? So these platforms have been designed so throughout their life cycle they can be moved up to 3 times. So you could deploy it, say, in a water depth of 50 feet, for instance, on the first one, come to the end of that field's life, plug and abandon, decommission the trees, then we can disconnect the platform and its components, put it back on a barge, move it over to a different water depth, use the same components again, just change the depth, the size of the jacket connector, and reinstall it again. And it is as simple as snap them together and break them apart. And it's all using proven technology. The other thing that we have in the deck structure of these particular platforms is they're plug and play. It's a flat deck structure giving you real estate, but you can have up to 8 wells on them, and you can plug and play into that your modules that you need, whether it's water disposal and treatment, 3-phase separation, pumping, chemical injection. They plug into the deck. So there are only 4 connections to make the mechanical connection for a module, and then 6 process connections. So you can literally plug in modules as you need them. Now, why did we come up with that type of solution? It's quite simple, because when we're looking at field development for really tight marginal fields, we want to go out with the minimum amount of equipment we need to get the field up and running. And as the process matures, add the process modules or any other modules that we need only when we need them. And then when we don't need them, we can remove them again. And that's one of the keys. And all of these modules that you see, the lower base, the jacket connectors, and the top deck, are all pre-configured with their I-tubes, J-tubes already on them. And that allows for expandability, which gives you another benefit. If you want to add a well in or a subsea satellite, you want to tie it back in, you don't have to make the modifications to the platform. Everything's already there to enable you to do it. So it becomes a development tool in a very easy and tight configuration. It's shallow. It's about 2/3 the weight of a conventional jacket for the same water depth. And it's got the functionality that we were looking for this particular application. Okay, Tom? So project management, this is the overriding thing that I like to talk to. And this is the one that I get excited about from my side, because this is where we interact directly with the customer. And having a single team that the customer interfaces with is incredibly important. And it's important from a continuity aspect of it, but it builds up the confidence level everybody acts as one group with full transparency. And it's incredibly rewarding to actually watch the process of our project teams interacting directly with the customers, especially in the first phase, where they jointly begin to feed off each other and develop solutions to make their assets more economical and deliverable. And it is very rewarding. The other thing that the group prides itself on is the ability to work with a customer, gather up their initial information, whether it's the reservoir characteristics, the field infrastructure, and the met oceans. And within 24 hours, we can go back to them and say, if the shallow water iEPCI solution with the ecosystem, as we just discussed, will actually work for their project. And we're very clear with this, and we're very upfront with it. We want to get the customer to this where he can make his asset work. And if there are an alternative solution that isn't in there, we'll direct them to another part of the organization that can better fulfill his needs. But we can do all that within the first 24 hours of actually sitting down in front of the customer, which is very a rewarding process. And again, it builds trust and confidence in the solution going forward. And it's going forward with a single team that is quite good with this, because these are all proven experts. They've done this many times. They've worked with numerous customers on their solutions that they've built up through their career that they can actually bring to bear. And that kind of gives us the edge when we're doing this, the customer, that you have the confidence in the team that you're actually doing to openly discuss areas which could affect the viability of the project, the deliverable, or even the long-term application for it when it comes to actually reusing the assets. And they can all be discussed and aired very early on in the project. And then mitigation plans and alternatives looked at and developed. So the project management and the life of the field is very important to us in there. And it's one of the most rewarding parts of the whole solution that we bring to bear in this case. Okay, Tony. So I mentioned very early in the first part of this quick talk, the digitalization. We've got to, it's the digital control system that covers everything. And this is where, it's a word that gets used quite a lot. So digitalization. But for us, what it means in this space is it's using digital to actually improve our safety. And by that, I mean removing the need to go offshore. Now, whether it's a platform, it's removing the need to go offshore and do regular maintenance and cycle tests. It's not getting away from having to do maintenance, but it's to remove the frequency. And I'll talk about that just shortly. But using a digital platform over everything you see in the foreground here that covers, it interlinks every aspect of the deliverable in the shallow water ecosystem space. And that's one of the best things that we can actually bring to this. And we use our own control system over this, which is an open architecture system. And that enables us to interface with a lot of other customer supplied equipment and what they have in the legacy field. So it makes it very simple for us to take our ecosystem, our digital ecosystem, and bring it into a customer system, or vice versa, incorporate their systems into ours for going back to the controller. And that gives us the added benefit of real-time communication to the field. And let's just go back and talk to that. Move to the next slide if you could, Tony. So, improved safety, I was just talking about that. And this comes back down to the single interface. So everything on the, we'll take the platform for instance. So everything on the platform is fully instrumented. And we take all the instrumentation back into the center control room. Now we couple that together with all of our predictive maintenance packages that govern that. We also include some of our thermal cameras that we have on the platform for complete visual inspection and thermographic inspection. So all of that's brought into a central control system. And it goes into the predictive maintenance algorithms that start detailing out when things need maintaining. And the overall goal we had with that, and the platform space in particular, was to limit the number of visits to the platform to no more than 14 days outside any form of well intervention, which we're parking. So any form of regular maintenance, we don't want to be doing anything more than 14 days visits a year. And that was a goal that we set for us. And that keeps the platform in a low intensity bracket, which was very key. And why is it safer? Because we're not putting people offshore. And the whole focus of this is to remove the need to actually visit, to go offshore and visit places for maintenance or for visual inspections. So we employed an awful lot of smart technologies within the core designs. And they translate through to the subsea hardware as well, because the predictive algorithms are in the subsea hardware, and it all works together within the network, within the ecosystem. And that comes down to having the right technologies that can link in and provide meaningful data to the system to enable the system to make some educated decisions for you, and to say these are components that actually need to be looked at and tested. So that brings me to another little point, which is right at the very end. When we were looking at this, the platform side in particular, and the subsea side, when we were integrating subsea wells and the platforms together, we ran into a problem where there was always this need for well testing. Well testing came up quite a lot in most of the discussions that we've had with the customers. And it was the frequency of the well testing, how much they wanted to do it, and the more or less the regular aspect of having to calibrate equipment to enable them to do the well test. And of course, it's labor intensive. So what we looked at the problem, and we worked with one of the customers to trial an idea, and we came up with a smart production manifold. Now, smart production manifolds address that directly. They're built into the platform design, and they can take the inputs from the subsea wells and the platform wells at the same time. But it enables the operator to test any well he wants from the control system. He can run it through 2 multi-phase flow meters, a single multi-phase flow meter, or the system can be pre-programmed to test his entire wells on a sequence. And again, to address the maintenance aspect of it, we can then use the 2 meters to calibrate each other. So again, it limits the need for doing that. So again, it's using product-based smart technology fully integrated with a digital platform to deliver solutions that require less boots on the ground offshore and less maintenance cycles. And that improves your overall operating expenditure when you actually look at it. So that's why the digital aspect in this space is quite important for us. So if we go on to the next slide. Tony, if you could advance me one. There we go. Thank you. So I use this one as a bit of a recap. So within the ecosystem, the shallow water iEPCI ecosystem, we've got configurable platforms that can suit varying water depths. And the big takeaway from these platforms is they're completely reusable. You can use them in multiple locations, using the same components, just adding a connector in the middle. And of course, they're plug and play, which is the big thing. Go out there with all you need to get started and add and subtract as the field matures up until the point when you actually move it over or decommission it. It's very simple to decommission. We have our shallow water tree systems, the JXTs, jacket standards, that again are configured to suit their specific application, and they can be run in a dedicated fashion or in conjunction with a platform to deliver the correct field solution. And then we have our infield flow lines and our umbilicals that are all part of our core supply. Again, configured to suit the shallow water space that can all be installed from our own vessels. And you take that and confirm it with the tie-in ability to enable us to make the connection to the host or the beach, whichever it is. But if you take all of that as our products and take the section to the right where we do have our integrated project management, our ability to actually work with the customer from the very early stages and engineer a solution that fits them specifically and economically, it adds a great deal of benefit. And then cover it with the overarching digital application of taking in the predictive maintenance modules, having the remote control ability, and the ability to monitor the site adds a significant value. So I'll pause for a minute and just to let you soak that up. But that takes us nicely to the end of the introduction to the shallow water iEPCI ecosystem. I'd just personally like to thank my management for allowing me the time to do this, and to OTC for granting us some airtime to allow us to take this forward. And with that, I'll pass it back to Tony for questions.
Ian, thank you very much. That was an excellent presentation. We actually got a first question from Mr. Patrick Robertson, who is joining us from YouTube. Patrick asks, would you consider a business model based on lease for this type of technology?
It's a good question. We've looked at it, and it really depends on the application, the time, and the location. So I wouldn't discount it. It would be something we could look at, but it's very specific. And that does come up in some of the conversations we're having with customers at the moment, where it is. But then they see the application for the longevity of it and moving it over different applications, and we then change the narrative as we move forward. But that's a good question.
Very good. And just a reminder to the audience, you can learn more about shallow water iEPCI in TechnipFMC.com. We've actually released a series of ecosystems, really interesting ecosystems since last year. We released iComplete for onshore unconventional stimulation, iProduction for onshore unconventional production, and of course, shallow water iEPCI is a subcategory of our very well-known iEPCI ecosystem from our subsea division. Okay, Ian, so I believe there was a comment in your presentation about the single digital interface that this ecosystem has. Could you share a little bit what that interface is, how it works, and perhaps share a little more about how it enhances safety in the field?
Yeah, I can touch a little bit about our overriding software interface is UCOS, which is our own software system. It's our own platform. It's very much an open architecture one, but all our inputs come into our UCOS system, where they're marshaled. Then we have our predictive maintenance algorithms that can sit over and above that. But where it actually comes in to improving safety is giving us the ability to pre-plan our maintenance, pre-plan the activities, and then predict areas where things can and may go wrong, so we can address them and mitigate any downtime issues. So when it comes to the safety, it's all about removing the necessity to actually put people offshore on a regular basis. I mean, some of these smaller jobs that we've been looking at, they've estimated that their maintenance visits are, twice a month. And, as soon as you start getting into that amount of visitations, and when you have a look at them, they're all to do with maintenance visits, site inspections, walking around the platform, for instance. And when we can get to the point where we can visually inspect the platform using the camera systems and our other methods, link that back in so the operators actually get real-time view of everything that's going on in the platform, and couple that with our vessel avoidance system in there, there's an awful lot we can actually do to walk back the amount of time that you actually need to visit the platform. And that's one of the best things we can actually do. Limit the amount of time that you actually have to put people offshore is one of the best ways to improve the safety of that.
Excellent. Thank you very much. We actually got another question from a YouTube user. His question is how to measure the cost saving related to continuously well testing with smart production manifolds versus conventional method.
Well, I mean, we're talking about we're literally talking about testing the wells. Now, often it's a case of putting in a well test module. Let's just treat it conventionally, where we have a well test package on the platform. Your cost for that is you're actually mobilizing a team to actually conduct that work for you most of the time. And there is the occasion where it actually requires certain amount of pipe work to be altered, or valves, or blanking flanges to be removed to enable you to do that. When we looked at the smart production manifold and where we were wanting to do that, we wanted to have the system, it's permanently installed. The product coming from the wells is routed through the boundaries of the pipework within the skid. The tested product is spiked back into the production line as well, but it's all controlled by the system. So when you're running a cost comparison against that, it's looking at how much cost you're actually incurring to actually put people out there to do it, how much incurring capital expense to actually put the well test module in there and run it. So I wouldn't like to actually go in the tail on the donkey, so to speak, and give you a number for that, because each case is different. But you can easily see that if you aren't having to put people out there to conduct the well test or set up the well test, and you have the ability to run sequential well testing, the reservoir engineers are going to get a lot more data when they need it to enable them to better monitor the actual reservoir itself. So I'm not entirely sure if I'm addressing the exact point of the question, but I think I've given you the background to say where we think we're coming from.
Thank you, Ian. I think another interesting aspect to share with the audience is, so you've had a lot of conversations with customers globally. So what has been the reception so far from our customers, and what questions have they asked and that you found are interesting about the system that's actually going to solve a problem, a pain point for our customers in today's very challenging environment?
Well, the pain point's quite easy. Let's just back into this. The pain point's easy. They have a collection of reserves that they can't actually do anything with, or they just failed to meet economic sanction point. And the reserves are stuck there. The most rewarding thing we get when we're talking to customers, and we're actually working in the Americas, we're working in Southeast Asia and the Middle East, and developing solutions with customers at the moment. And they all more or less share the same, it's almost the same epiphany when they're engaging with the project teams. And it's a common theme that runs across the board. They all approach these pooled reserves, shallow water pockets with very much the same methodology. And that can be developed through years of doing different feed studies or working together solutions that deliver very traditional ways of looking at it. And it's working with them as a team to come to the same realization as there's a better way to do it. It's more cost effective, and that asset that we couldn't do anything with, we can now do something with. And when it comes to one of the biggest ones, it's simplicity. I think that would be the big thing. Everybody gets surprised at how simple the system can actually be. It doesn't need to be complicated. And one of the things that we do, and we're quite open about it when we're talking to the customers, is we'll push to get them the most economic system possible. And it's always a surprise to them the fact that the simplest solution ends up being the one that they actually gravitate towards, because it makes it feel viable, for one, and two, it's easier from a maintenance standpoint. So it gives them it is an epiphany to watch it as it develops when you're with the customer.
Very interesting. We just got another question. It's actually two questions from Mr. Eka Rora in Kuala Lumpur. His first question is, how do you define marginal fields? That's a really good question. And number two, are there other future applications on CCS which this system could leverage?
Okay, so let me take them one at a time. And Tony, I might need you to remind me on the other one, but let me just take the first one. So the marginal fields, stranded or pooled reserves, these are assets that our customers own. They may have owned them for many, many years. And they've had numerous ways of looking at it, but they've never actually been able to take it through to internal sanction point. And by definition, they end up being stranded. So that's about the best definition I can actually give for you. It's small pooled reserves that, as a standalone project, they just can't make the grade. And even in the tieback, the economics are against them to actually make them viable for the customer. Our goal in that respect is to come in, look at it holistically, and move the needle in a favorable direction. And that's one of the things that our teams enjoy doing. Now, to the second part of the conversation, yes, all of the solutions that you've seen here have a viable route in to enable the carbon capture and permanent sequestration. And they're perfectly suited for that. The shallow water trees can do that. The platform in particular is suitable for that, where you can actually group a number of injectors together and then run a sequence manifold to actually vary the injection pattern so you get even plume distribution. So that's something that TechnipFMC are looking at, and we have a team that's actively exploring that. But to your point, the shallow water iEPCI ecosystem is perfectly suited for inshore carbon capture and sequestration.
Excellent. We have another question from Mr. Resk, and the question is, what are the main challenges in smart production technology for Industry 4.0?
That's a good question. Smart production technologies. Well, I mean, sort of personal opinion here when it comes to smart production technologies. I'd love to see us develop a route to actually break the carbon off the product as it comes out of the well, and that's, you know, that's something I would love to see. I would also like, and we're actively working on this as well. There's programs in place within the shallow water development group to compress the size of our process facilities. So on the another, for instance, for the modular process on the platform, I mean, we can handle in one module, the larger module, we've got up to 30,000 barrels a day of liquids. But the ability to actually get that compressed down would be very advantageous for us in numerous applications. And we're actively working on that. So if I was to characterize something I would be looking to get forward in the process side more and more, it'd be get that carbon captured as it comes out of the ground, and let's get our processing down to a manageable size. And we're working on some fairly active technologies in that space.
Thank you, Ian. And again, everybody, if you want to learn more about our shallow water iEPCI ecosystem, you can visit our website, look in the surface section of the website. You're going to see some good surprises. You can learn either about this system or iComplete or iProduction, as I mentioned, and we have a really nice new product tool that allows you to get a quick, big picture overview of everything that we do in our surface division. So visit TechnipFMC.com, follow us on LinkedIn. I want to thank Ian for this extraordinary presentation. We're all very excited about the shallow water iEPCI ecosystem. I want to thank the audience and thank OTC for giving us the opportunity to present this ecosystem, and hope to hear from you soon. Ian, thank you very much.
No, you're welcome. Thanks.
Bye, everybody.
Thank you.
So if you're asking yourself why you should attend OTC this year, first of all, our world-class technical program that will address multidisciplinary topics. Every other year we have an exhibit floor. The exhibitors are very anxious to welcome face-to-face interaction with their customers. They've been wanting to talk to everyone face-to-face for the past 14 months, and in August they'll finally get their opportunity. We've experienced tremendous support from exhibitors, sponsors, registrants, and the general community in Houston, who are all ready to see OTC come back in person at Energy Park. And we invite everyone to join us August 16th to the 19th.